want to look at solutions of triangles in mathematics. How do we solve triangle problems? But before we go deep into the method we use in solving triangle problem, we have to look at some factors that will build up what is called triangles. Now, let's look at what is meant by a triangle. As the name implies, triangle means three angles. The side that brings it together is 3. We are having 3 angles that are joined together. These 3 angles is also made up of 3 sides that bring it together. This set of information I've provided, 3 angles and 3 sides, are what we call elements of triangle. In other words, triangle have 6 elements. 6 elements of triangles are 3 angles and 3 sides. It has 3 angles and 3 sides. Then we have to look at what is the value of those angles that we have inside the triangles. The sum of angle in the triangle, in L triangle, sum of angles is equal to 180 degree. Whichever value is given to you at any angles, we have to make sure that the sum of angles in that triangle must be equal to 180 degree. It is important you take note of all this information. Now, the next thing we need to know is to look at different types of triangles that we have. Types of triangles. The number one we have here is called the scaling triangles. Scaling triangle. In scaling triangle, all angles aside are of different value. All angles and the sides are of different value. So it does not say this is a value that a particular one we have, but all angles and sides must be of different values. Number 2 is what we call the isosceles triangle. In isosceles triangle, the 2 sides are of the same value, while the base angle will have the same value as well. It has a triangle with equal 2 sides and equal base angle. Another one we have is called the equilateral triangle. Equilateral triangle. This is a form of triangle where all the angles and sides are of equal value. All the angles and sides are of equal value. All angles and sides are of equal value. In that regard, it's going to have each angle to be equal to 60 degree. Each angle is equal to 60 degree. If you multiply 3 by 60, you are going to get 180 degree. Since we know that the sum of angle in a triangle is 180 degree, so this is the value for each side of what we refer to as equilateral triangle. Another one we have is called the obtuse angle triangle. Obtuse angle triangle. Obtuse angle triangle. This is a form of triangle with one of its sides greater than 90 degree. Triangle with one side greater than 90 degree. That is what we refer to as the obtuse angle triangle. Another one we have is the triangle we call the acute angle triangle. Acute angle triangle. The triangle with none of its sides up to 90 degree is a triangle that none of its side is one of its angle, none of its angle is up to 90 degree. We can easily say that a very good example of acute angle triangle is going to be equilateral triangle because each of the side is 60 degree, so they are not up to 90 degree. So, e.g., equilateral triangle. Equilateral triangle. Another one we have is called the right angle triangle. Right angle triangle. Right angle triangle is a triangle with one of its angle equal to 90 degree. One of its angle equal to 90 degree. Excuse me, for the obtuse angle triangle, this is a triangle with one angle greater than 90 degree. Take note of that. Thank you. Now, after we have looked at the types of triangles we have right now, the next thing we want to look at, where do we apply triangle method of solving question in mathematics? What are those topics that you are to be expecting yourself to face with the problems of triangles? Let's look at those topics where you can encounter triangles in solving problems. Now, application of solution of triangles. The following topics are the topics where you are expected to see a method of bringing in triangle to solve the problem. Let's look at those topics. The topics are as follows. Number one, we have angles of elevation and depression. Angles of elevation and depression. We also have another one we call the bearing and distance. Bearing and distance. In this set of topics, you are going to make use of a triangle in solving most of the problem there. Number three is called the trigonometry. Trigonometry. Number four, that is about triangles itself. Number four is called the geometry. In this form, you're going to see a triangle inside a circular object. Number five is what we call the construction. Number six, we have another we call the plane mensuration. Under plane mensuration, and we also have the one we call the solid mensuration. Among the topics where you are going to see a triangle problem coming into play, let's now look at method of solving triangle problem. That is the next topic. Method of solving triangles problem. In solving triangle problem, we have to consider the types of triangle that the problem can lead to. We have the triangle. For the solution of triangles, the triangles that we are going to be considering will be right angle triangle and non-right angle triangle. A right angle triangle, as I have said earlier, is a form of triangle that has one of its angle equal to 90 degree. That is, one of its angle is a right angle. Now, what are the methods we can use in solving the problem of right angle triangle. In right angle triangle, it looks like this. This is an angle that is called 90 degree. It is like this. It is a perpendicular, it is an angle that a straight line that goes towards the x-axis is perpendicular to the x-axis line. So it is called a 90 degree or a right angle. And this whole triangle is called right angle triangle. Now, the side that faces this right angle is called the hypotenuse. While this side, this is the angle we are considering. If we are considering this angle, the side that is opposite to this angle is called the opposite side. While the top side, or the side that is a base to the angle in consideration, is called the adjacent. So we are having the three sides of triangle here being named as hypotenuse, opposite, and adjacent. Now, to find the value of any of the side of this right angle triangle, we make use of what we refer to as Pythagoras theorem. Pythagoras theorem states as follows. States hypotenuse square is equal to opposite square plus adjacent square. That is the value of Pythagoras theorem. It says that hypotenuse square is equal to opposite square plus adjacent square. In this world, it means that if two sides are given to us, for us to find the third side will be very, very easy. Another method we can use in solving problem of right angle triangle is by the using of trigonometric functions. The trigonometric primary functions are the sine, cosine, and the tangent. Those are the trigonometric functions, the sine, cosine, and the tangent. It is from there you can deduce some other values of trigonometric like cosec, cotangent, or secant. Now, this set of information here can be used to define the value of either the opposite, hypotenuse, or the adjacent, that is the size of the triangle, and can as well be used to determine the angles that we are looking for. Now, the sign says we have this set of information we call the SOHCAHTOA. This means sine is equal to opposite over hypotenuse, where this O means opposite and H means hypotenuse, where cosine means adjacent over hypotenuse, and tangent means opposite over adjacent. These trigonometric functions can be used to find the value of either the sides or the angles, while Pythagoras theorem can be used to find the size of the right angle triangle. We can now move to non-right angle triangles. Non-right angle triangles are the forms of triangles where none of its angle is equal to 90 degree. None of its angle is equal to 90 degree. And for us to be able to find the values of either the sides or the angles of non-right angle triangle, we can make use of two approach in deducing or finding the values of the angles or the side in non-right angle triangle. They are the sine rule or cosine rule. Those are the methods we use in finding solving the problem of non-right angle triangle. Now, for sine rule. Sine rule states that the side is the side is proportional to the angle opposite to it. Each side of a non-right angle triangle, non-right angle triangle is proportional to the opposite angle. It's in that regard, if you have a kind of triangle like this, where none of its angle is equal to 90 degree. If this place is A, the side here will be called small letter A. This is angle A. This is angle B. This side will be called small letter B. And this is angle C. This side will be called small letter C. It means that these rules of the sine rule says that A over sine A equal to B over sine B equal to C over sine C. It means that each side of a non-right angle triangle is proportional to the opposite angle. Is proportional to the sine of the opposite angle. Let me work that out for you. For instance, let's take A for example now. A is proportional to sine A. Where A, we are going to make a constant when we have this proportional sign. We are going to create a constant when immediately we change it to equal to K sine A. Where K will be equal to A over sine A. So that is why we say each side is proportional to the sine of angle opposite to it. Let's look at cosine rule. Cosine rule information is as follows. It is applied for non-right angle triangle. Take note of that. A square is equal to b squared plus c squared minus 2bc cos a. In cosine rule, this is a side. The side that is equal to all the information here, we also have its cos to hand here. B squared as well will be equal to a squared plus c squared minus 2ac cos b, where c squared will be equal to a squared plus b squared minus 2ab cos c. This set of information are what we refer to as a cosine rule. When do we need, what are the conditions, or when do we apply sine rule and cosine rule? What are the values or the side that will be given or the angle that will be given that will make us to know this is a particular rule I have to apply in solving this non-right angle triangle? What are the conditions to determine which rule to use in solving non-right angle triangle? For you to solve non-right angle triangle, you either think about using sine rule or cosine rule. Now, for sine rule, for you to use a sine rule, it's either two angles or all the three angles on one side are given. One, two angles or all three angles and one side is given. So you can make use of sine rule for that kind of condition. Another condition is that when you have two sides and an angle opposite to one of the side is given. Two side is given and angle opposite one of the side is given. That is another condition you will meet in making use of what we call the sine rule. Another condition is for cosine rule. When do we make use of cosine rule? When two sides and one angle between them is given. Two sides, that's number one. Two sides and one angle between them is given. When two sides and one angle between them is given, you can make use of cosine rule. Another condition that you can use in making use of cosine rule is when the three sides of the triangle are given. When three sides of triangles are given, then you can make use of the cosine rule. Those are the conditions you can meet in making use of either the sine rule or cosine rule. Now, let's look at some problems involving sine rule and cosine rule as we solve it right away. Take turn, please. We have a question here on the right angle triangle. The question says, calculate the value of x of an isosceles triangle with base equal 24 centimeter and equal sides of 15 centimeter each. We are asked to calculate the value of x here. You can see that this is an isosceles triangle. These sides are equal to one another. That is why this sign is put there. And this base line is 24 centimeter. We are asked to calculate the value of this x here. Now, for us to calculate the value of this x, you will see that this side, this line is the one that divides this triangle into two equal parts. Therefore, this side from here to here will be 12 centimeter, while from this place to the work would be 12 centimeter. Don't forget that 12 centimeter, 24 centimeter can be divided into two to be 12, 12. Now, if this place is 12 centimeter, this place is known to be 15 centimeter. This is angle 90. That is a perpendicular line with the horizontal. In that regard, we can call this place an hypotenuse. This place is going to be, this is our side, our angle that is to be provided. We call this place the opposite, and they call this place the adjacent. So using Pythagoras theorem, we can say that hypotenuse square is equal to opposite square plus adjacent square. Where is this value of hypotenuse? That is the side that faces the right angle. That is 15 squared is equal to, what's the value of opposite? S squared plus adjacent square is 12 squared. Therefore, S squared will be equal to, taking S squared as the subject of the formula here, we are going to have, that will be 15 squared minus 12 squared. Where x squared will be equal to, what's the value of 15 squared? 15 squared will be 225 minus 144. 225 minus 144, x squared will give us 81. Where, to find the value of s itself, we find the square root of both sides. X squared is equal to 81 square root. Find the square root of L. This one will neutralize this. Therefore, x is equal to 9. So the value of x is equal to 9 centimeters. So the value of this side here is 9 centimeters. That is how you get that. You can see that we make use of Pythagoras theorem in solving this kind of problem here now. So let's look at another question as we look at how to solve it right now. The question here says, a ladder 40 meter long rests against a vertical wall. If the ladder makes an angle of 65 degrees with the wall, find the distance between the foot of the ladder and the wall. That is what the question says here. This question, according to what the walls looks like, let's look at it this way. A ladder makes 40 meter long, rests against a vertical wall. This is a wall. The ladder rests against it. You know, when the ladder rests against the wall, this is how it looks like. If the ladder itself is 40 meter long. If the ladder makes an angle of 65 degrees with the wall, this is where it touched the wall, 65 degrees. Find the distance between the foot of the ladder, this is the foot of the ladder, and the wall. This is the foot of the ladder and the wall. So we are asked to find this place. Distance between the foot of the ladder and the wall. If you look at this question very well, you see that we've been able to construct the question to make it to become a triangle. Now, this is obvious, 90 degree. Now, if this place is 90 degree, this place is going to be the hypotenuse, because it is the side that faces this 90 degree. And this side is the opposite of the angle that we are given. Where the adjacent is the wall. That is the base of that angle given to us. This is the adjacent now. In this regard, I can now use my trigonometric function to solve this problem. Which of the soccer tool can be applied to make use of opposite and hypotenuse? Yes, we can make use of sine. You can now see sine, what is the value here? 65 degree is equal to opposite x over hypotenuse, that's 40 meter. In this case, we are having a fraction on this side, just a single term here. This one is as well equal to over 1. Then what do we do here? We make use of our cross multiplication. That is sine 65 multiplied by 40 equal to x times 1. Sine 65 multiplied by 40 meter equal to x plus 1. In this regard, you can now say that x is equal to sine 65 multiplied by 40. What is the value of sine 65? Thus 0.9063 multiplied by 40. So x will be equal to 36.25 meter. So this is, so x can be approximated to become a whole number to be 36 meter. So this x here is 36 meter. That is how you get such a provide a solution to see kind of problem. You can see in the first question we make use of Pythagoras, sorry. Why here we make use of a trigonometric function. Take note of that. Let's now look at how we can apply some rules, the cosine rule, to solve some triangular problems. Another question we have here says, in triangle ABC, A equal to 41 degree, side B equal to 4 centimeter, side C is equal to 6 centimeter. We are asked to find the value of side A and the angle B. Now, how do we solve this? Let's draw the triangle first. This is, let's say this is A, B, and C. This is 41 degree. It is obvious to us that this is a non-right angle triangle. It's a non-right angle triangle. Then we are given the side as 4 and 4 centimeter, and C as 6 centimeter. We are asked to find this side first. Now, this is going to be our small letter A. That is our side A. Ordinarily, we can make use of this. Since we have been provided with two sides and one angle. So we can make use of this. A squared is equal to B squared plus C squared minus 2BC cos A. We can use this method to simplify this value here. We are going to have A squared equal to B. What's the value of B? 4 squared plus C squared minus 2 times 4 times 6 cos what's the value of A? 41 degree. This is going to be equal to A squared will be equal to 16 plus 36 minus 2 times 4 times 6. That's 2 times 4, that's 8 times 6. (48) cos A. What is the value of cos A there? 0.7547. 16 plus 36, 0.7547. Let me follow us solve this, please. Multiply by 48. 36.22. We have A squared equal to 52 minus 36.22. That's 15.78. So we are A. We have to find the square root of both sides now. 15.78. Find the square root of that. So this one, neutralize this. We have A equal to, what's the square root of 15.78? This is 3.9797 centimeter. So A is 3.97 centimeter, approximately 4 centimeter, because the rest of the value are in 4 centimeter. They are in whole number. So I try to make it to be an whole number here. Now, we have been able to get the value of A now. We need to have the value of B. In this case here, we make use of cosine rule. To find the value of B, we can make use of sine rule to simplify this angle B by saying A over sine A equal to B over sine of angle B. We have the value of our A already. 4 over sine for the 1 equal to B over, what is the value of B? We have this already as well. 4 over sine B. Sine, by cross multiplying, we have sine B multiplied by 4 equal to 4 times sine 41. 4 multiplied by sine 41. We have sine B will be equal to 4 multiplied by sine 41. (2.6242) divided by 4. We have to make sine B the subject of the formula. A divided by 4. Sine B is equal to 0.6561. 0.6561. Now, for us to find the value of B, B will be equal to sine inverse of 0.6561. You know, what I did here is to divide both sides by sine. So when I divide both side by side, this one will become all this value here over sine. That is meaning of sine inverse. Sine inverse, then our B here will now be equal to sine inverse of 0.6561. That is for the 1.003. For the 1.003, approximately, B is approximately 41 degree. 41 degree. That is the value of B as well. Is not up to 90 degree. What is the value of C? Though we are not asked to find the value of C in the question given to us, but let's think about how we find it. Since we know that the sum of angle in this triangle is going to be equal to 180 degree, so the value of C can be easily found by just saying C will be equal to 180 minus 41 plus 41, that's 82. 180 minus 82, that will be equal to 98 degree. 98 degree. 98 degree. Now, what kind of triangle is this? This is obviously an obtuse angle triangle. Obtuse angle triangle. Why? One of its angle, 98 degree, one of its angle is greater than 90 degree. So that is why it is an obtuse angle triangle. We can see that we have been able to make use of the cosine rule and the sine rule on just a single question. So you should be expectant. Thanks for taking part of this class. See you next time.